All right, today we're putting on our detective hats. We're not just going to look at some code, we're going to crack a case. We're going to solve a classic puzzle that honestly reveals a really powerful way of thinking, a strategy that's at the heart of so much problem solving. So let's get into it. Okay, picture this. You're in a huge, crowded room, and your mission is to find two specific people who together are a perfect match for some weird requirement. How would you even start? Well, that's basically our mystery today, but we're going to be doing it with numbers. You know, every good detective story starts with the case file, a clear objective. And this is ours, the twoSum challenge. It's a super famous problem, and for good reason. It teaches a lesson that goes way beyond just programming. So here are the rules of the game. We get a list of numbers, our suspects, and one target number. Our job is to find the positions in the list, the indices, of the two numbers that add up perfectly to that target. Sounds simple enough, right? But how you do it, that's where all the cleverness comes in. Let's look at our first piece of evidence here. The list of suspects is 2, 7, 11, 15, and our target is 9. A quick look tells you, yeah, 2 plus 7 is 9. But remember, the solution isn't the numbers themselves, it's their positions. The number 2 is in the very first spot, which we call index 0, and 7 is in the second spot, index 1. So the answer we need to give is 0, 1. Now, we could try to solve this the hard way, checking every single possible pair, but a good detective works smarter, not harder. They use a tool to keep track of all the clues. And for us, that tool is going to be a special kind of notebook. And here it is. This is the big strategic twist. Instead of hunting for two numbers at the same time, we're going to look at them one by one. And for each number, we're just going to ask one simple question. Hey, have I already seen the partner you're looking for? And this is our secret weapon. In the coding world, it's just an empty dictionary, which you'd write as seen equals empty. But for our investigation, think of it as a fresh, empty notebook, just waiting for us to jot down clues. Our notebook has one very simple rule. Every time we see a number, we write down two things: what the number was and exactly where we saw it, its index. This creates this super handy map, right? A way to instantly check what we've seen before. All right, notebook in hand, let's go investigate the scene. We're going to walk through that first example step by step, just like a detective on the job. Let's start with the very first number on our list. Our first suspect is the number 2. It's sitting there at index 0. So what's the first thing we do? We ask a question. And the logic is pretty straightforward, right? If our target is 9 and the number we're currently looking at is 2, then the partner we need has to be, 7. It's just the difference. So the next logical question is, have we seen a 7 before? Let's check the notebook. We flip open our notebook and it's empty. Totally blank. I mean, we're just starting our investigation, so of course we haven't seen a 7 yet. No match. So we can't solve the case yet. What do we do instead? We make a note. We just jot down our first clue, saw the number 2 at index 0. Now our notebook isn't empty anymore. This little clue might come in handy later. Okay, notes taken. Let's move on to the next suspect in the lineup. Next up, we've got the number 7 at index 1. And it's the same process all over again. We've got our suspect, now we ask the question. So, if our number is 7 and our target is 9, the partner we're looking for is a 2. And we ask that same question again. Is the number 2 anywhere in our notebook? Let's check it out. And yes, it is. We flip open our notebook, and there it is, our very first entry. We have seen a 2 before, and our notebook tells us exactly where, at index 0. We've got a match. And just like that, case cracked. We found the pair. The number we needed, 2, our notebook told us was at index 0, and our current number, 7, is at index 1, and that gives us our solution, 0, 1. Awesome. So, we solved one specific case, which is great. But the real power here is in the method, because it's a method we can use over and over again. Let's just quickly formalize the strategy we used so we can apply it to any twoSum case that comes our way. Okay, here's the playbook. First, you'll look at a number. Second, you figure out the partner it needs. Third, you check your notebook for that partner. If it's there, bam, you're done. Return both positions. If it's not there, you just make a quick note of the number you're on and where you saw it, and then you just move on to the next one. That's it. That is the entire repeatable process.
What we just did, it's actually more than just solving a little puzzle. We've uncovered a really fundamental idea in the art of problem solving, especially in computer science. It's all about the trade-off between time and memory.
I mean, think about it. The brute force way would be checking every single combination. Does 2 and 7 work? Does 2 and 11? 2 and 15? Then you'd have to start over with 7 and 11. It's slow, it's exhausting. But the smart way, our detective's way, we just look at each number one single time. We use a little bit of memory, our notebook, to save a massive amount of time.
And that really gets to the core of it all. The solution here wasn't about raw power or trying every single possibility. The genius was in the preparation, the decision to use memory to store information. That's what made finding the partner instantaneous. We traded a tiny bit of space for a whole lot of speed.
And that leaves us with a final question to chew on. This whole pattern of remembering what you've already seen to make future decisions faster, it's absolutely everywhere. It's how you find duplicate files on your computer. It's part of how recommendation engines work. So what other problems out there could you solve not by working harder, but by working smarter with just a simple notebook?